This is a 2023 final exam paper and we are doing question 4. So it says sketched below is the graph of f of x equal to 2 to the power of x minus 4. For x is an element of negative 2 to 4. A and b respectively, the x, the y and x intercept of f. So there's nothing fancy about the statement. Let's rush the first questions. Okay, so the given functions here are given as f of x. F of x is equal to 2 to the power of x minus 4. What type of a function is this? It's an exponential function. I want you to note something. Here we actually have 1 times. If there's nothing in front of a base to the power of x, just know we have 1 times. So let's look at 1. 1 is positive. This means our graph must be above the asymptote. And can you see the asymptote? Here is the asymptote. This asymptote. This line here is the asymptote. So the graph is above the asymptote. And because b, the value of b, which is 2 in this case, is more than 1. Therefore the graph is increasing. It's going up as you move from left to right above the asymptote. So make sure you watch the theories before you actually go to the actual question papers. The question 4.1 for 1 mark says write down the equation of the asymptote of f. Remember what we said, that we read the asymptote here. So what is our asymptote? So we can say that 4.1, our asymptote is given as y is equal to minus 4. And that is 1 mark. Fair enough, right? So we are moving to the next question. It says, determine the coordinates of b. What is b? Let's look at what is happening at b. First thing you must ask yourself when they say do something. Ask yourself what's happening at the point where they are saying do something. That is at b. B is a point where the graph touches the x-axis. This means we are talking about the x-intercept. And remember that for x-intercept, you always say let your y be equal to 0. So we're going to solve for x because we know that y is 0 on the x-axis. So we're going to say that let f of x be equal to 0 because we know that f of x means the same as y. So we're going to say that 0 is equal to 2 to the power of x minus 4. And then we're going to say that 2 to the power of x is equal to 4. If you can't change bases, just write it in a logarithmic way. Remember, our x will become the left side, and we're going to say that x is equal to the logarithm base 2, the exponent, the number there, is 4. And then if we do that correctly, we're going to get that our x is equal to 2. So, because they want coordinates, the coordinates of b will be given. We have the x value of the coordinates of b is 2. But when the values of y are 0. So we're going to say that the b is 0, is 2 and 0. Make sure you answer the question. Don't just write 2. They want the coordinates. So it's 2 and 0. And those are our answers. And we're going to erase here. So I hope it's clear to everyone. So 4.3 says, determine the equation of k. A straight line passing through a and b in the form k of x equal to. So note something here. They want the equation of line k. So let me plug in a line here. The line will pass through a and b. So let me see if I can drag it nicely between point a and b. There it is. So what is it? It's a straight line. Okay, and we know the coordinates of b. They are given as 2 and 0. Let me further erase them. So the coordinates of b are given as 2 and 0. Do we know coordinates of a by any means? Let's see. To get the coordinates of the coordinates of a, what is happening at point a? Point a is when the graph touches the y-axis. It means it's the y-intercept. So remember, for y-intercept, we always say let x be equal to 0. And then to get the values of y, already we have the value of x at point A is 0. because that's on the y-axis. So we're going to say that f of x, or f when the values of x is 0, is equal to 2 to the power of 0 minus 4. Then 2 to the power of 0 is 1. 1 minus 4 is equal to minus 3. This means that the coordinates of a are given as the value of x is 0 when the value of y is minus 3. So those are the coordinates of a. I'm sure there will be a mark for finding the coordinates of a first. So make sure you have all the necessary tools. When I'm saying the tools, I mean all the information needed to be able to tackle the question. So coordinates of a are given as 0 and minus 3. And we're going to find an equation of a line. Check my video for introduction to linear functions. You'll be taught on how to find an equation. First of all, you must know the gradient or the slope. M is equal to y2 minus y1 over x2 minus x1. And then this will be x1 and y1. And this will be x2 and y2. If it's x1, it must go with y1. So what is y2? y2 is minus 3. So it's minus 3 minus 0 over 0 minus 2. And at the end, we're going to have minus 3 over minus 2. And because you will use a calculator at the end, your answer will be 3 over 2. That is your gradient. And remember that your equation is given in the form y is equal to mx plus c. Y is equal to mx plus c. We're going to plug in your gradient. Y is equal to m, that is 3 over 2x plus c. So what is c? C is the value of a, the y-intercept. We said that c stands for the y-intercept, and we have calculated the value of y at point A. Remember, it was given as minus 3 when we found it before. It's this one, it's minus 3. So without wasting time to calculate the coordinate or the value of c, we can therefore say that y is equal to 3 over 2x minus 3. And this is how we can do it. So make sure you're able to grasp this. So our answer here is given as y is equal to 3 over 2, and it's x, then minus 3. Then we are going to erase since we are working with a limited space here. And we are going to move the next one after I finish erasing. Okay, so we are now on 4.4. Calculate, they say write it in the form k of x equal to, you see, we didn't answer the question. So 4.3, the answer to 4.3 is actually, they want it in the form k of x equal to, so we're going to say that k of x is equal to 3 over 2x minus 3, and that is how they want it. They say in the form k of x equal to, so I'm sorry for that, it must be in the form k of x is equal to. Then we're going to 4.4. Calculate the vertical distance between what? Between k and f at x equal to 1. Between k and f. Okay, so this is how we can do it. They're just trying to play around with you. Remember coordinates of b. Here the value of x is 2, and here the value of x is 0. So what they are saying here is that we have got a straight line here, which is k, or k of x, but they said k. Then we have a parabola below it. Okay, and this is the point b. The point b, which is 2 and 0. And here we have the point A. The point A, which is 0 and minus 3. What they are saying here is that somewhere, let me use a different color, is that somewhere we're going to have a vertical line at x equal to 1. So they want the distance of this vertical line. They said the line, that is what? Calculate the vertical distance between k and f. See, the line must be between k and f. So this will be the blue line at x equal to 1. So there's something important which I want to tell you, that for a vertical distance, always when they say calculate a vertical length or a vertical distance, you must say the values of y at the top minus the values of y at the bottom. And then to get the horizontal length is the one that goes from right to left or left to right. So the horizontal length is given as x right, the value of x on the right side, minus x left. So this is how I could explain this in short terms. So first of all, because they wanted the vertical height, I must say the value of y at k. K is the line that is on the top, you see. So I'm going to say that the value of y at point k minus the value of y at point on the graph of f. Okay, so let's determine the value of y on point k, where the value of x is 1. Okay, so we're going to find k when x is 1. It's given as, that was 3 over 2 times 1 minus 3. And let's see what we get there. It's 3 over 2, and then minus 3. Then the answer is minus 1,5. I'm just going to write that as a decimal, minus 1,50. Because it's a length, just write units, just for the sake of inconvenience. No, that's not a length, that's a coordinate, sorry. So it's 1,50. And then we're going to determine the value of y on f of x, on the exponential, when the value of x is 0 as well. So here we're going to look for f of 1. It's given the form f of x, right? Yeah. So we're going to look for f of 1. We're going to say that f of 1 is equal to 2 to the power of x, which is 2 to the power of 1 minus 4. What is 2 to the power of 1 is 2, minus 4 is minus 2. So let me erase here. Because we are looking for the, I erased here, that's f of 1. Because we are looking for the vertical length, I'm going to say that the graph that is above is the graph of k. It's the graph of k, and it's the graph of f. That's why I say k minus f. But if the graph of f was on the top, I was going to say f minus k. So the way in which I'm going to do this, I'm going to say that y top minus y bottom. That's going to be, I'm looking for the distance. We can say that length is equal to y top minus y bottom. What is y top? The value of y the top on k is minus 1,50 minus the value of y on the bottom, that is minus 2. And if we say minus 1,5 minus 2, we get minus 0,50. Because it's length, we're going to say units. Make sure you plug units as long as it's a length. So make sure you understand this. For a vertical length, always you will say the value of y on the top minus the value of y on the bottom. But if they wanted a horizontal line, you're going to say that is x right minus x left. I hope that is clear to everyone. So I'm going to erase here. And then they say to you, we're moving to what? 4.5. Determine the equation of g, given that f of g of x is equal to f of x plus 4. Okay. So they're saying to you, g of x is equal to f of x plus 4. It's very easy to interpret this. This is for 1 mark. It means we don't have to sweat a lot. So g of x is equal to, where we see f of x, we are going to plug, where we see f of x, we're going to plug 2 to the power of x minus 4, because that is f of x, right? So I'm going to say that 2 to the power of x minus 4, and then plus 4. There's something important that an examiner did here, but many people might not be aware. What they do, they added 4. Where did they add 4 to? To the value of q. This means we are dealing with a vertical shift here, shifting of up and down. We said downward is negative and upward is positive. So what they do, they shifted the graph of g 4 units upward. They said plus 4. So we went plus 4. we added 4 to the value of q. I hope it is clear. So our graph, to get the graph of g, we must shift the graph of f 4 units upward. So this is how we do it here. So what is the question here? The question says determine, write down the equation. So we can say that g of x is equal to x to the power of x. Because negative 4 plus 4 is equal to 0, let's say plus 0. Therefore, g of x is equal to 2 to the power of x. And we are done. So determine the equation of g. We can say that g of x equal to 2 to the power of x. Then 4.6, write down the domain of the inverse of g. Okay. So g to the power of minus 1 stands for the inverse. Remember, I've shown you a notation for the inverse in one of the lessons. So our g of x, we say is given in the form 2 to the power of x. Okay. And what is the range and the domain? I've told you that whenever they start plugging the inverse of an exponential, they're talking about the logarithmic graph instead. So we have to know the range and the domain first, because we know that the domain for the logarithmic graph will be the inverse of the range of the exponential. So what is our domain here? The domain for the exponential is always x, an element of real numbers. What is our range? Here we have plus 0. Okay, so this means that first of all we must know the shape. Here the graph is above the asymptote because it's positive. So we can say that y is greater than 0. As long as your graph is above the asymptote, you're going to say that y is more than. Okay, so y is more than the number that is here, because here we have nothing. If here we had 2, we're going to say y is more than 2. But because we have nothing, we can say that we have plus 0. Then our range becomes y is more than 0. So now we're talking about g of minus 1. G of minus 1. I said this symbol stands for the inverse. Okay, so the inverse of an exponential function is the logarithm. And they are looking for the domain of the logarithm. The domain of the logarithm is equal to the range of the exponential. So because they want, the answer for 4.6 will be, they want the domain of the logarithm. The domain of the logarithm is the range of the exponential. But where we see range, we just say domain, because we said we swap, right? Then, because it says y is more than 0, we're going to say that the domain here is x is more than 0. Make sure you repeat that video for logarithmic functions many times as you can. To get the inverse, g of minus 1, when they say g of to the power of minus 1, f to the power of minus 1, k to the power of minus 1, h to the power of minus 1, they stand for the inverse. And an inverse of an exponential function it gives us the logarithmic function. And the domain of the logarithmic function is the range of the exponential function. And the range of the exponential function gives us the domain of the logarithmic. Then you have to switch between x and y. Where we see y, we switch. Remember we said, when we are determining the equation of the inverse, when we are determining the equation of the inverse, we swap the x and the y value. That's the first step. So make sure you are able to understand everything which I have said here. Then they say to you, write down the equation of g of minus 1 in the form y of x. They want the inverse of g. So we said that g of x, so I can erase here to get our g of x on its own without 0. So our inverse is given as g of x is equal to 2 to the power of x. So we can write it as y is equal to 2 to the power of x. Where we see x, we put y. Where we see y, we put x. So x is equal to 2 to the power of y. Remember, the y becomes the left side. This one becomes the base. And this one becomes the number. Then make sure you are able to do this. I've said this in the video for how to use logarithmic geometric series or sequence in the playlist for number patterns. Make sure you understand this. So we're going to say that the left side is y. Y is equal to the logarithm base 2 the number which is x. This is how we write it. But because they want it in the form y, then it's okay. They say write it in the form y equal to. Always listen to the instruction. Write this in the form y equal to. Let me tell you how they mark the equation for the inverse. First of all, the 1 mark is for swapping. You have swapped here. So there's 1 mark for swapping. There is 1 mark for swapping, and there's 1 mark for final answer, provided it's written in the form y equal to, as they've stated here. So make sure you are able to do this. This was November 2023 NSC final exam, question 4. So the questions for functions are very easy. Make sure you practice them. Practice makes perfect, but perfect practice makes perfect. So make sure you practice, and then at the end of the day, you will thank yourself. And feel free to ask in the comment section for further clarification. Thank you for watching.